Alright, what's up guys? In this video we're going to pick up with some calculus here. This is going to be another integration practice video. I'm going to show you guys how to evaluate the following integral. So the integral that we're going to evaluate here is the integral x squared minus 4x plus 11 all over x minus 3 times x minus 1 times x plus 1 with respect to x. So all we really need to do here is take the partial fraction, and luckily for us, the denominator is already factored down into these linear terms, so there really is no amount of work to do in terms of factoring or anything. That's already done for us. So we just need to set up our partial fraction decomposition and find the values of our unknown, or our unknown constants a, b, and c. Alright, so we'll get a over x minus 3 plus b over x minus 1 plus c over x plus 1. We need to multiply both sides of this equation by this denominator here. So we need to multiply this side over here. I'll see if I can fit it over here. We need to multiply this side over here by x minus 3 times x minus 1 times x plus 1. And we need to multiply this side by the same thing. X minus 3, x minus 1, x plus 1. And then we'll simplify it here. So if we simplify it, we'll get x squared minus 4x plus 11. And it looks like we'll get a multiplied by x minus 1 multiplied by x plus 1. Then it'll be plus b multiplied by x minus 3 multiplied by x plus 1, and then we'll get plus c multiplied by x minus 3 multiplied by x minus 1. Okay, so now what we need to do after doing our partial fractions and doing the reduction, we need to find the values of these unknown constants, or we need to figure out what they are. There's two ways to do this. The most popular way to do this is by substituting in some values of x to see if you can solve for the constants. That's typically the more popular way. The second way of doing it is by equating coefficients and solving the system of equations. Most students don't like doing it that way because it takes a little bit more work. But unfortunately, in certain situations, simply picking values of x just won't work. In this particular case, we can just pick some values of x to solve for the unknowns, but I would say don't get so stuck on doing it that way. You may have to do it the other way in some cases, but we don't have to do that here. So let's say we want to solve for a. Well, if we want to solve for a, we need to pick a value of x that we can plug in here that's going to cancel out the other variables. So in this case, let's say, for example, if we let x equal 3, well, we know 3 minus 3 is 0, so if I multiply b by 0, remember b is an unknown constant. It's kind of operating, although it doesn't have a specific value, it's kind of operating like a number. Anything times 0 is 0. So although it's an unknown constant, it's a constant. So we want to get it where b will be multiplied by 0, c would be multiplied by 0, cancel it out so we can solve for a. So we need to let x equal positive 3. So let's substitute in a positive 3. So we'll get 3 squared minus 4. And we're going to sub in a 3 for every place we see an x. So it's going to be 3 minus 1. This will be 3 plus 1. Then this will be plus b. This will be 3 minus 3. It's actually going to be 3 plus 1. And then c, we got 3 minus 3 multiplied by 3 minus 1. Alright. So these will cancel out. And we'll simplify over on this side. So on this side it looks like we'll get 8. I'll get rid of the equal sign on that side. Looks like we'll get 8 is equal to, looks like it's going to be 8a. So that means that a here is going to be positive 1. Now we need to pick a value of x to solve for b. So the best selection in this case obviously would just let x equal positive 1. So we need to sub in a 1. And we have to sub it in for every place we see an x. So it'll be 1 minus 1, 1 plus 1, plus b. We'll sub in a 1, so it'll be 1 minus 3. And what am I missing? Yeah, if we want to solve for b, we can let x equal 1. Just make sure here. Yeah, this will be 1 plus 1. Sorry, just checking, make sure I ain't going off track here. And then we got c. We'll have 1 minus 3, and then 1 minus 1. Alright, so what I was double checking was just to make sure that I would in fact cancel those out. So yes, they do cancel. A goes away, and so does c. So the substitution x equal 1 does work. And so it looks like we'll get 8 over on this side. It's going to be equal to negative 4b. So b in this case, if we solve for it, it's just going to be negative 2. So now we need to pick a value of x so that we can solve for c. The best selection would be negative 1. So this would be negative 1 squared minus 4 times negative 1 plus 11. It's going to be a. This would be negative 1 minus 1. Sorry, no, put it in parentheses. Negative 1 plus 1, which you know is going to give us 0. And then we'll have plus b. And we'll have negative 1. Looks like we'll have minus 3. We know it'll work because negative 1 plus 1 is 0. And then it'll be plus c, and we have to stick that in as well. So it'll be, I'm putting everything in parentheses, so it'll be negative 1 minus 3, and then negative 1 minus 1. Sorry, I had to fit it in there. Sorry, it's a little small, but I had to fit it everywhere in. Okay, so we know that a is going to go away. We also know that b is going to go away. So looks like we're going to get 16. And looks like it's going to be equal to 8c. Now if we solve for c here, we'll simply get c is equal to 2. So now we got the values of those constants. Took me a minute, but we got them. So now we got x squared minus 4x plus 11 all over x minus 3 times x minus 1 times x plus 1 dx. The integral now becomes the integral of 1 over x minus 3 minus 2 over x minus 1 plus 2 over x plus 1. And this needs to be integrated with respect to x. So we took an integral that we didn't know how to do and turned it into one that we do know how to do. And it's very easy to tell what the answer is going to be here, so we're going to go ahead and write it. So in our case, our answer is going to be ln absolute value of x minus 3 minus 2 ln absolute value of x minus 1, and then it'll be plus 2 ln absolute value of x plus 1 plus c. And that's your answer. So make sure that you can integrate these natural logarithms because you're going to be seeing those a lot in partial fractions. Okay. So remember, the antiderivative of 1 over x minus 3, that's ln absolute value of x minus 3. The antiderivative of negative 2 over x minus 1 is negative 2 ln absolute value of x minus 1. And the integral of 2 over x plus 1 is 2 ln absolute value of x plus 1. And all you have to do is tackle a c on. And that's your final answer. Alright, I'll see you guys next time.